Elections these days feel more polarized than ever, with each side seemingly locked into their own camp, divided by a widening gulf. It's as if the middle ground has disappeared, leaving voters feeling that they are forced to pick between two extremes rather than a shared vision, unable to connect with either option on the ballot. And if you are like many people, you might be wondering, does my vote even matter? George Washington once called democracy the great experiment, a system of self-governance by the people, a powerful yet fragile construct. And Winston Churchill, in his classic wit, said that democracy was the worst form of government except all those others that have been tried from time to time. So here we are. Democracy is messy, it's chaotic, and yet somehow it's the best we've got. Democracy relies on something simple but vital: our participation. But what happens if people stop showing up? Or what if they feel their voice doesn't matter because neither candidate fully represents them? In the 2020 US presidential election, only 66% of eligible voters cast their ballot. A third of the people did not vote. And I'm pretty sure a lot of them felt abstaining was the best option and probably was a statement in itself. But here is the twist. Math, physics, and a few scribbled equations show us how abstention and low voter turnout do more harm than good. In fact, they can make elections so unstable that the outcome does not represent the public at all. Today, we'll dive into a fascinating research paper from 2020 by Alexander Seigenfeld and Yanir Bar-Yam, published in Nature Physics, on negative representation and instability in democratic elections. They uncover something remarkable. The way elections become unstable and polarized is a lot like how metals become ferromagnetic when they're cooled down. To understand this, let's take a quick physics detour. Imagine a metal like iron. Normally, the tiny atomic magnets or spins within iron are randomly oriented, each pointing in its own direction. But as we cool the iron down, below a certain critical temperature, something amazing happens. Suddenly, these spins begin to align with one another in a coordinated way, creating a strong magnetic field that we can actually observe. This shift, where an initially random mix of spins with a net zero magnetization snaps into alignment, is what is called a phase transition. The material is said to have entered the ferromagnetic phase. This is what we study with the Ising model, a mathematical model that captures how individual spins or tiny magnets interact with their neighbors. In the model, each spin can either point up or down. At high temperatures, spins are too energetic to settle into alignment, so they stay mixed up. But as the temperature drops, the spins start influencing each other more strongly, encouraging their neighbors to align in the same direction, making it more stable. This means it can settle into one of two distinct configurations, either all up or all down. Below that critical temperature, a tiny nudge, like a small external magnetic field, can flip the entire material into a magnetized state with all spins either pointing all the way up or all the way down. Now, Seigenfeld and Bar-Yam discovered that as societies become more polarized, democratic elections can also undergo a similar phase transition. Beyond a certain critical level of polarization, small shifts in the opinion can lead to big swings in who wins, sometimes even in the direction opposite to the majority opinion. This means that the election outcome can flip between extremes, which might sound a bit familiar in today's politics. Now, to be clear, humans are not like tiny electrons with spins, but the key connection is correlation, complexity, and emergent behavior. Here is how we can model this. In their paper, Seigenfeld and Bar-Yam map our political landscape onto the real line. The real line X, where each X represents a certain political opinion. The origin corresponds to the centrist opinion. All the positive numbers can be thought of as all right-leaning opinions, and all the negative numbers can be thought of as the left-leaning opinions. Now, in this space, the distribution of people's opinions, for example, will take the form of a curve. Let's call that curve as f of x, as a function of x which represents the fraction of people that hold a certain political opinion. In their model, we imagine the electorate is split into two clusters or peaks of opinion, one left and one right. The distance of these peaks from the center, which we'll call delta, measures the polarization. A high delta means more people with extreme opinions and therefore more polarization. A low delta, that's a more centrist society with many opinions close to the middle. What Seigenfeld and Bar-Yam show is that depending on the characteristics of the opinion distribution, f of x, the possible election outcomes can be modeled by the same mathematical expression, which governs the physics of the Ising model of interacting spins and how they turn ferromagnetic. The parameter h encodes information about the relative heights of the left and the right peaks. If h is 0, equal number of people lean right as they do left. If h is positive, more people lean right, and on the other hand, if h is less than 0, more people lean towards the left. The election outcome, let's call it y star, can be read from this plot on the right where the two curves, the straight line and the hyperbolic tangent, intersect. When delta equals 0 and h equals 0, there is one outcome at y star equals 0, a centrist result. In a usual stable election with low polarization, for example, here I choose delta equals 1, there is a single solution that represents the public opinion well. If opinions shift slightly left, h going negative, so does the winning candidate. If they slightly shift right, the candidate follows. This is democracy at its best. Small opinion changes lead to small shifts in outcome. This stability happens when polarization is low, where delta is small. But now here is when things get, well, unstable. As the differences between the electorate become more pronounced and more polarized, left and right diverge, and more people hold more extreme opinions. The election undergoes a phase transition from being stable to unstable. Beyond a critical polarization, the election outcome, y star, is no longer unique. It has multiple possible solutions, each very different from the other. A small change in the electorate's distribution or other factors can lead to big swings in the election outcome, from extreme right to extreme left. It's just like the magnet. As you cool it down, depending on the fine interplay between different spins and the applied magnetic field, the net magnetization can either be north or south, very distinct from each other. For example, as we tune H to be more left-leaning, there are still possible solutions to the election where the outcome swings right. Slight variations can have a giant swing in the outcome. These variations might include changes in population, or nuances in the candidates' personalities, or even changes in the rules between a simple majority election versus an electoral college system, for example. Other things like voting restrictions or the effectiveness of campaigning can all have an impact on this. From election cycle to cycle, the outcome can swing between these two vastly different subpopulations. Things get even more interesting. A leading cause of instability is non-voting. Imagine being stuck between two candidates, none of whom really represents you. You might think abstaining is the best option. But here is what Seigenfeld and Bar-Yam found. When a lot of people abstain in a polarized election, it actually ends up destabilizing the outcome. This is something called negative representation. For instance, consider a race between a centrist left-leaning candidate and a candidate to the extreme right. As the polarization of society goes up and left-wing individuals move further left, they may become less likely to vote for the center-left candidate, choosing instead not to vote, which increases the probability that the candidate on the right will win. They prove mathematically that election instability cannot occur without negative representation, which itself stems from low voter turnout. Intuitively, when not many people end up voting, the candidates are incentivized to go and turn out their bases rather than winning over centrist voters, something we see increasingly happen in today's elections. This isn't just theory. The authors observed that the US presidential elections underwent a similar phase transition in the 1970s. Before then, centrist candidates would often win, but as polarization increased, that's when things started to change. That's why we nowadays see such big swings between different candidates with such extreme opinions every cycle to cycle. The authors analyzed data on the fraction of polarizing words in the platforms of the Democratic and the Republican parties from 1944 to 2012. This content-based measure of polarization shows that starting in the 1970s, there was a marked increase in the divergence of language used by both parties, suggesting a phase transition in the elections, going from a stable to an unstable regime. You can literally see the language of our political parties drifting apart over the decades. The math is cool and enlightening, yes, but the message is solemn. Your vote matters more than you think. Democracy is the great experiment, and it's something worth preserving. When we all participate, we are not just voting for a candidate or just to have our voice heard. We are actually voting for stability, for a democracy that works. Even if the choices don't thrill you, showing up is an investment in a stable democracy. Get out there and vote, and I'll see you next time.